Welcome back to Code Trios. Today we are going to explore something every developer should understand to write clean and efficient programs. We are talking about abstract data types or ADTs. So what is an abstract data type? It is a model for how data behaves. It describes what operations you can perform with the data, but it does not tell you how those operations are actually built or implemented. Think of it like this. When you use a list in your program, you care about adding items, removing items, checking if something exists, or printing the whole list, but you do not need to know if that list is built using an array or a linked list. That is the power of an abstract data type. Here is an example. You create a list, you add the number 55, then 88, then 66, you print it, the result is 55, 88, 66. You never had to think about how those values were stored. That is abstraction in action. Now, behind the scenes and the list could be an array where items are stored at numbered positions, or it could be a linked list where each item points to the next one. Both work, both are valid, but the programmer using the list does not need to care which one is used. Let us try a simple mental test. If we start with an empty list, then we add 11, then 4, then 7. What do we get? The result is 11, 4, 7, 7, because we added them in that order. Now imagine a list that has 2, 20, and 30. If we remove the number 2, what is left? We get 20 and 30. Also keep this in mind. You do not need to know the internal structure to use the list, but the way it is built will affect how fast or slow your program runs. Arrays are quick for reading values by index. Linked lists are better if you need to add and remove items often. Let us look at some of the most common abstract data types. First is the list. It stores items in order and allows adding, removing, and searching. Next is the dynamic array. It works like a list, but allows quick access by index and resizes as needed. Then we have the stack. This works like a stack of plates. The last item added is the first one removed. The queue is like a line. First item in is the first item out. The decay lets you insert or remove items from both the front and the back. A bag is used when you want to store items but do not care about the order and allow duplicates. A set is similar but only stores unique items, no duplicates allowed. A priority queue gives each item a priority level. Higher priority items are handled first. Finally, we have the dictionary, also known as a map. This stores key value pairs. You can find a value by searching for its key. Each abstract data type can be implemented in more than one way. Stacks can use arrays or linked lists. Sets can use hash tables or trees. Dictionaries can be built for speed or for sorting, depending on the structure used. Let us match a few examples quickly. Which structure keeps the order you added items and allows duplicates? That is the list. Which one handles items by importance? That is the priority queue. Which one allows duplicates and ignores order? That is the bag. Which one keeps only unique values? That is the set. To wrap up, abstract data types are a way to think about data in terms of behavior and not construction. They help you build better programs by letting you focus on what you want to do instead of how it is done. Thanks for watching. If you learned something new today, make sure to like the video and subscribe to Code Trios. More smart lessons are on the way. Keep coding, keep learning, and I will see you in the next one.